You know how some apps are just blazing fast? You hit search and bam, the result is there. Ever wonder how that's even possible? Well, it's not magic. It's something called data structures and algorithms. And today, we're going to break down exactly what they are and why they are the secret sauce behind almost all great software.
Okay, to really see what I mean, let's start with a real-world story. This little tale shows you exactly why this stuff is so important. So, picture this. A developer writes a piece of code to pull some information from a database. They run it, and it takes 10 hours.
I mean, that's not just a little slow, right? For pretty much any real-world application, that's completely broken. You can't have a user wait half a day for something to happen. It was a huge problem.
But here's where it gets wild. After taking a step back, rethinking the problem, and applying some knowledge of data structures and algorithms, the exact same task went from 10 hours down to just 10 minutes. Think about that. That's a staggering leap in performance.
So what was the secret? The data didn't change. The goal was exactly the same. The only thing that changed was how the data was organized and the set of instructions the computer used to work with it. And that right there is the heart of everything we're talking about today.
To really get our heads around this, let's use a super simple analogy. Imagine we're building a tiny little map of a neighborhood, like our own mini Google Maps. This is perfect for understanding the first piece of the puzzle, data structures.
So we start by listing out all our locations, right? Home, store A, the school. And we give them coordinates. We know where everything is. But look at this table. There's something really important missing, isn't there? It doesn't show us the roads. We can see the destinations, but we have no idea how they're all connected.
And this brings us to our first big definition, a data structure. It's not about the data itself, the locations or the coordinates. It's about the way you decide to store and organize it. It's the framework, the container you build for your information.
So, to store our street connections, we have choices. On the left here, we could just make one giant list of every single connection. Home goes to store A goes back to home, and so on. Or check out the option on the right. We could organize it differently, grouping it by location. So for home, we list out all the places you can get to directly. Store A, store B, and so on. It's the same exact info, just structured in a totally different way.
All right, now for part two. We've got our data organized in a structure, but now we need to actually do something with it. So let's give our little map program a task. Find the shortest possible path from home to school.
To do this, we need an algorithm. And honestly, the best way to think of an algorithm is just as a recipe. It's a very specific step-by-step set of instructions that tells the computer exactly what to do to solve a problem.
Now you and I could probably just look at a simple map and see the shortest route. But a computer can't just look. It needs clear steps. So our recipe might look like this. Start at home and find all the direct paths. Then, from each of those new spots, find the next set of paths. All the while, you're keeping a running tally of the total distance for each route you explore. Once you have all the routes that actually end up at the school, you just compare their total distances and pick the smallest one. It's methodical, but it's guaranteed to find the best answer.
Okay, this is the magic moment. This is where it all clicks into place. We have our data structure, how our map is organized, and we have our algorithm, a recipe for finding the path. Now let's see how that first choice completely changes how well the second one works. Remember step one of our recipe? Find all the places you can go from home? Well, with option one, our big, long, unorganized list, the computer has to read through the entire thing, from top to bottom, just to find the lines that start with home. But with option two, bam! It can instantly jump to the home section and get the answer right away. It's the difference between searching a whole phone book versus looking up a name in the index.
And that is the absolute key takeaway. Data structures and algorithms are a team. They're totally linked. The way you structure your data can either be a giant speed bump for your algorithm or a superhighway that lets it fly.
This connection is how you solve that 10-hour problem and turn it into a 10-minute one.
So now you might be thinking, okay, got it. Option 2 is always better, right? Well, not so fast. There is no single best data structure. And to see why, let's switch to a new, fun analogy: organizing a party.
Imagine you're storing guest names on little balls. For System 1, you have a long box with numbered partitions, kind of like an egg carton. In programming, we call this an array. For System 2, you put each guest's name in its own little individual box, and then you tie them all together in order with a piece of string. This is what we call a linked list.
Okay, time for a little test. Task number 1. You realize you misspelled the name of the 98th guest to arrive. You need to find that ball and fix the name. Which system do you think is better for this job? For this one, the long box, our array, wins hands down. It's not even close. Why? Because you can just do a quick calculation to find the 98th slot and go directly there. But with the chain boxes, the linked list, well, you have to start at the very first box and follow the string, counting 1, 2, 3, all the way up to 98. Much slower.
Aha, but wait, there's a plot twist. 5 more guests just showed up at your door uninvited. Now you need to add them to your list. Which system is going to handle this curveball better?
And just like that, the tables have completely turned. With the long box, our array, this could be a disaster. What if it's already full? You might have to find a whole new, bigger box and then painstakingly move every single one of the existing guest balls over. Ugh. But with our chained boxes, the linked list, it's a piece of cake. You just grab 5 new boxes, write the names, and tie them onto the end of the chain. Done.
So, after all that, the maps, the parties, what's the big idea here? What's the one thing you should really walk away with?
It all comes down to these 4 things. 1. Data structures are simply different ways to organize information. 2. Algorithms are the recipes that work on that information. 3. And this is the most important one, your choice of structure directly affects how fast your recipe runs. And 4. There is no single best data structure. It's always about trade-offs and picking the right tool for the specific job you need to do.
So the next time you search for a photo on your phone, get driving directions from a map, or your social media feed refreshes in the blink of an eye, you'll know what's happening. Behind the scenes, there's this elegant, invisible dance between a well-chosen data structure and a clever algorithm making it all happen. They really are the unsung heroes of our digital world.